Raspberry Pi is a wonderful little board, something that's came out of Great Britain in the last decade. It's kind of harkens back to the days of when the Spectrum and the BBC Micro were the kingpins of the home computing scene, or at least in Europe. Tiny little computer that can work as a full-on desktop. It can be put into a whole load of things like portable computers or robots. It can be used for Internet of Things, so home automation. You know, it basically is a versatile little thing. And I like it because it works for me for retro gaming. There's an actual installation called RetroPie, which lets you basically run old games right up to, I think, about the PlayStation thereabouts, or at least successfully up to the PlayStation. But the problem is with the Raspberry Pi, it is very, very cheap. I mean, the most high-end board I think is about £35, but in order to get it to that price point, they have cut back on everything. You don't get a case with it, you've got to buy your own case. You don't get, it's basically a couple of USB ports, system on a chip, Ethernet, that's about it. And it doesn't have an on-off switch. You literally plug the power in, turn it on, make sure you safely shut it down in the operating system, and then pull the power out. Which is frustrating as hell, especially if you're using it as a little portable console like I am. So I wanted to rectify that. I've got the Raspberry Pi behind me here. Let's make a little power button for it. My name's Mark, this is Alienated Youth. Okay, so the Raspberry Pi, I'm using RetroPie now. Time about the road, but down here I've got my Raspberry Pi, I've got my monitor. If I wanted to turn it on normally, I would have to literally get up, put it in the, it's a USB power, basically a charger sort of thing, but it's irritating. So I've managed to do this little piece of board here, little button press. Takes a couple of seconds for it to kick in, and there we have it, RetroPie. I've got it hooked up to an Xbox 360 joypad, best way for me to use it really. So it works, runs off of emulation station, so you could look up that in its own right. How do I do that? Well, there's a, basically I've got it as emulation station runs off of Raspbian, it's basically a Linux distribution. And you can actually have a couple of little scripts running in the background. It's using Python because you can use the Raspberry Pi's GPIO pins. It's general purpose input output, and it uses Python to basically interact with that in the real world. You can use this with LEDs, with different kinds of temperature sensors, light sensors, etc. It's a good little electronics thing and really works really well. So for this case, we can actually hook it up using power buttons. It's brilliant. But the way I've got it set up, well, let's take a look at it. Okay, so on the left of the Raspberry Pi here, you can see the GPIO pins. I've got two cables hooked up, one to pin 5 and one to pin 6. Pin 6 is a ground pin. Basically, by shorting out pin 5 using the ground pin, that's what can set off the reset to halt the system. Cables are hooked up to this prototype breadboard, meaning I don't have to solder anything basically, and it's got the wee button there as well. That wee tech switch is what we've been using to turn it on. Obviously I've not got it hooked up to power at the moment, but that's the basic gist of it. So as you can see, it's a bit cumbersome and a bit, well, external. I mean, using a big breadboard like that for that is just like, what? Why? So I've got the top of the case as well, and over Christmas I decided, yeah, let's try and do new things this year. So I've also managed to get my hands on a soldering iron. So what I'm going to do is I'm going to make an actual power button on the front of the case so we can use it in that. Now, bear in mind guys, don't try the way I'm about to do this at home. This is me showing you the very first time I've ever soldered. I've probably made about 101 mistakes. Eek.
Well, before we get the button soldered on, there is a couple of things we need to do to actually get the button working in the software. So first of all, this is the first time you set it up, you need to go into the RetroPie menu, down into Raspbian config. This is the built-in configuration menu in Raspbian. From here we're going down into interfacing options, SSH, and we're activating SSH. This will allow us to actually go in to the Raspberry Pi via Windows, so we can actually add the code in that will allow the button to interface with the operating system.
Now, in order to put the code into the Raspberry Pi itself, we need to remotely enter using that SSH functionality. Here on Windows I'm going to be using a program called Putty. It's a free download I'll keep in the description. There's other terminal based programs you can use on Linux and Mac as well. You're logging in using IP address, it'll put up a local address, something like 192.168.0. something. You'll be able to find that in the IP config menu. And it'll be port 20 as well. You're logging in as Pi and password Raspberry. Now that'll be your default password and login. If you haven't changed that, you probably should for security reasons, but anyway. So once we're logged in, we're going to write a few scripts, or apply a few scripts into the system. So once you've got this screen up, you're typing in sudo nano listen-for-shutdown.py. This will open up in the built-in text editor. It's a Linux based one called Nano. Now the script I've put up on GitHub for you all. There's the link in the screen now. So basically what we're going to do is copy paste the script from GitHub. It's at github.com/alienated-youth/raspberry-pi-button. Once you're there, you click into listen for shutdown.py and just copy the full script there. Once you've done that, we go back into the terminal window and we're just pasting that into this file. Using Putty, it's a right click on to paste it in. It'll be different depending on what program you use, obviously. Once we've done that, Control X to close the file down, press Y to save the file, and then when we're back in terminal, we've got a couple of commands to type in. So what you want to do is type in sudo mv listen-for-shutdown.py /user/local/bin/, and this moves that script into the local bin folder on the Pi. Next you want to type in sudo chmod +x /usr/local/bin/listen-for-shutdown.py, and that will make the script executable by the system as well. Sorry, just bear with me with the typing. Normally a lot faster typer, but sometimes it can take a bit of time. Especially when I'm reading my notes. Okay, so now we've got the Python script done. That's the one that will actually interface with the GPIO pins on the Raspberry Pi. We need to write a shell script to make the system recognize it. So it's sudo nano listen-for-shutdown.sh. Grab the script from the GitHub repository again. Same deal, copy paste. So that'll be listen-for-shutdown.sh script. Paste it into Nano. Control X to close down Nano. Press Y to save the file. So now we've done that, we've got to move that and make that executable as well. So it's sudo mv listen-for-shutdown.sh. This time we're putting it to /etc etc/init.d/. and we need to make that executable as well. So it'll be sudo chmod +x /etc/initd or init.d /listen-for-shutdown.sh. So now we've got our Python script that will interface with the GPIO pins on the Raspberry Pi. We've also got the shell script to run the Python script in the system. But now we need to enable the script to run at startup so we can actually check the GPIO pins and allow it to run. So the following commands we're going to put in will also start it up, so it'll just run from now as well. So you want sudo update-rc.d listen-for-shutdown.sh defaults. And then we're also putting in sudo /etc or etc/initd /listen-for-shutdown.sh start. So that will start the service. It will start checking the GPIO pins to see if the button's been pressed, to see if that circuit's been closed. So it will run the shutdown script if it is. So if all goes according to plan, and if the button works, once everything's been plugged in, you press the button, those scripts will run and it will shut this system down safely. On to the fun bit.
Okay folks, so this is everything I've got ready to install this button onto the Raspberry Pi properly. So you can see I've got two jumper leads, male and female, but it's only the female end we'll need for the Raspberry Pi to actually put in. Sorry, get in camera that. I have a little tack switch. This is going to be going into the case. The idea is it will go on the front here, or at least it will. I'll probably be gluing it onto the case, but I'll probably do that first. So you can see it there. You can just use that to turn the Raspberry Pi on and off. Wire cutters / strippers, full on tool I've got, which is quite good. Soldering iron, solder. So let's get to it.
I've sped this bit up because, let's be fair, this was my first attempt at soldering and it was a really messy job. Long and short of it, I glued the button onto the case and I soldered the two cables. Once I'd cut off the ends of the cables to solder them directly on, I left the female plugs on the cables because they plugged into the GPIO pins on the Pi. It was my first attempt and yeah, I did make quite a bit of a mess of the case at the end, a bit melted off. But hey, all in all, we got there in the end and it is all holding together.
So there we go, we've got the pins hooked up. As you can see there, it's GPIO 5 and 6. So now we're just going to put the case back together properly. So, bear with me. See, yeah, it's a little messy at the front. I can probably fix that a little bit. Let's get it hooked back up and see how it goes. Okay, so I've got the Pi set up again. It's all enclosed in its case, everything's hooked up. Let's press the power button and see if it's working. Wait for it to kick in properly. Success! So there we go, we have a working power switch in RetroPie with the Raspberry Pi. All nicely self-contained in its own case as well. It's brilliant, fantastic. What would I do differently? I would have learned to solder before I actually did that, properly. On the plus side, I didn't burn the house down, I didn't wreck any components, apart from super gluing one tack switch to myself and wrecking one little wire, but you know what, that's small fish, I'm not actually complaining about that. Again, don't do it the way I did it. I know that's why I fast forwarded through the soldering bit. again, that was my first attempt at soldering, and I'm quite glad it's actually worked, so hey, Hail Mary for me. So I've put the scripts up on, as you see earlier on, they're up on GitHub. The link will be in the description. And yeah, so now I'm going to use that through the year to do Alienated Retro. Yay! Yeah, so like, share, subscribe if you enjoyed what you've seen today. And of course, if you've got any comments about, please feel free to fire them into the comments below. And of course, you can get in touch with me at MarkDRQueen on Twitter. My name's been Mark, and catch you guys soon.